I'm going to talk about Earth's history. So Earth, like Big Bang happened, like in the beginning of the universe. Then like 10 minus 6, the atoms formed right after the Big Bang. Like 10 minus 6, photons forms, proton forms. 100 seconds later, then helium and hydrogen are synthesized. 100 million years from now, and later after the Big Bang is first star formed. 500 million years, current record holder for the earliest known galaxies, and 4 billion years, our solar system formed. So I'm gonna talk about Earth's history actually. So 225 million years ago, all the continents were sticking together except part of Europe and North America. Then North America, South America just split it a little bit, and but it's more water, it's like more water than today. Need to open Readable. It's not Readable. So in Jurassic, like 200 million years ago, the there was northern hemisphere, like North America, like Mexico, like anything below Mexico is gonna be like full of water, except South America and in Africa. There's some water in the northwest of Africa and northern of South America and southern of North America. Just 200 million years ago. So like anywhere in between like South Asia, it's gonna fill with water, but North Africa is for the water. But like in Africa, it's still Africa, it's still their land, it's still there. Except that there was an island near this side Africa, but it's joined. So Antarctica was like Antarctica, like anywhere below it's like Himalayas mountains is the lands moved to Antarctica, but Australia hits like Antarctica. That was 200 million years ago. So in Jurassic, 100 million years ago, there was like water. You have to show the map so you can't see. So anyway, in like central Mexico or Florida, actually central Mexico and South Florida, if it existed. So it's gonna be some water until it hits tip of South America. Yeah. So Africa and South America is gonna be like a river. Looks like a river from the map, but it's just water streaming to like Africa and South America. Then anything below the Himalayas is this island. The land is gonna be in the middle of the ocean between like Asia and Antarctica. The land. So in Australia, Australia is connected to Antarctica. 65 million years ago, when the dinosaur went extinct, North America and Europe, there was water in the middle, looks like a lake or something in front of the map. The size of a lake, but it's not. So like anything below the Himalayas, there was land in touching the equator or India. So in Australia, there was connected to Antarctica, and Atlantic Ocean got bigger than 150 million years ago. But land was, when I say land, like in mid of Asia and Antarctica, that's India. But you have to talk about the whole world names for its history. So if you want to see like, so like historically, for now, like current weather or something, we want to see the what weather, like what's the weather yearly around. You have to look at the like the average temperatures, average temperature and snowfall. That's like best thing we find, like how much snow on the average. It's the best way to find how much snow on average instead of what weather. The weather is gonna change yearly depending where you live. Mm, Instead of that, you have to look at average temperatures and average precipitation. That's the best thing, like best thing because the weather changes yearly. This weather is too unpredictable historically to guess what's the normal snowfall. So I'm gonna talk about the ice cores proof. So like there was strong evidence of past climate conditions by preserving layers of snow and ice trapped atmospheric gases and other material formation. And this reveals changes in concentrations like greenhouse concentrations like temperatures and other factors too. So if we understand past climate, we could understand this current climate and the future climate. And layers of ash like volcanic, volcanic sulfates, and it records past volcano eruptions. That was ash and volcanic sulfate. So the past climate changes have been changing like for decades. Well, sometimes it could be, there's so like climate change is every decade instead of years, sometimes it's years. So for example, the ratio of oxygen minus 18 to oxygen minus 16 that that says that proves that the temperature of in the ice varies. No, the ice varies with the temperature of if oxygen 18 to oxygen 16, the ratio was. If, so I didn't talk about fully the climate. So like around 800,000 years ago, the Earth's average temperature was close to today. Between 800,000 years ago and 600,000 years ago. So 20,000 years ago, the climate was 6 degrees colder than today. So I'm gonna go directly to the different giant cloud. 5 million years ago. So in 5 million years ago, the temperature was like around like like 4 degrees higher than today. The Earth's average temperatures was 4 degrees higher than today. 4 degrees. So the Earth's average temperatures combined with all the climate stations combined for the world. So like 100 million years ago. So the Earth's average temperature was like 7 degrees warmer than today in 100 million years ago. So 250 million years ago. So 250 million years ago, the temperature was 10 degrees or more warmer than today. Like 1991 to 2020's average. 250 million years ago compared. So in 2.4 billion years ago, it's gonna be like much. It was significantly warmer than today. The climate was 2.4 billion years ago was significantly warmer than today. Warmer, and the CO2 was like 3,000 to 9,000 parts per millions of CO2 in the atmosphere, and this no widespread ice. The sun was dim. Yeah. So 1.5 billion years ago from now is gonna be like sun is gonna expand to a red giant because the sun is burning hydrogen. The average global temperatures during snowball Earth was around minus 50 degrees Earth's average temperatures. And the temperature in the poles, like North Pole, South Pole, is like minus 70 degrees during snowball Earth. So like climate is gonna get drier. We're gonna talk about future climate. So when climate is gets very warm, the deserts will expand. Like head north, and the subtropical high gets stronger, and subtropical low gets. Actually, the high subtropical pressure belt is gonna get more north and brings the Amazon get climate get drier. And some places the low pressure gets more north and it makes it more rain, like in subtropical low. Anyway, if I say in a continental change like land moving, that's India. Because you need to talk about the whole world for its history, not just in Toronto. this was a small lands like billions of years ago, beyond like 250 million years ago, but this short form like LAAM and SK. So yeah, so you can say no then. So so the climate was changing before. So in the future, there's no and not gonna be any humid continental climate in 250 million years from now. If we controlled the weather and controlled the climate, since, or just like naturally, it's normal humid continental climate. So in Mars, like its pole is like there's some subarctic climate or ice cap climate in the South Pole. Actually, mostly like most part of South Pole is like ice cap climate. If we terraform Mars and make Mars like Earth's average temperature match to Earth's average temperature, so it's gonna be ice cap climate at the poles. But in there's some warm summer and hot summer continental climate in somewhere in Mars. Like if we terraform Mars, in this desert climate somewhere near the equator, this like everything is the same as Earth. The subtropical high and subtropical low is same thing as Earth. The whole thing. So like if we but there's a problem when in Mars, like it's terraformed. Even if you make it like a south in the pole, south pole, north pole, like to humid, warm summer, humid continental, there's not enough land for humans to live. If it gets too warm, so like for billions of years, there's no going to be any humid continental climates. There was human continental climate in the past, like Earth's history, like 5 million of years, between 5 million years ago and today. So humid subtropical climate. So humid subtropical climate is closer to tropical climate, even closer to oceanic climate, even closer to human continental climate. So it's like mix of all oceanic climate and human continental climate. And so subarctic climate is long cold winters. It's like closer to Arctic like climate. So like hot desert climate is we're gonna talk about lettuce. So hot desert climate is BWH capital make it be capital okay so just put like BWH that's hot desert climate and the cold desert climate is cold desert climate is BWK, that's cold desert climates. So it brings like cold winters and hot somehow, like warm summer. Hot summer or warm summer. Similar to like warm summer, humid continental climate. No, it's not similar. So the subtropical high Crete deserts, which is located like in 30 degrees and 40 degrees latitude. So this also like when yeah. So tropical rainforest is AF, with tropical monsoon or tropical monsoon is AM, and tropical savanna is AW. That is Köppen climate. Those ice deserts. So how this cold deserts form? It didn't. It forms because of rain showered blocked by mountain ranges. By low. So like it's so in like so Toronto's future, like Scarborough, for example, somewhere in the 2000s, it's gonna be warm to hot summer continental climate. We experience. Or like in the end of 2000s, like 2075, like 2071, it's gonna be like humid subtropical, like I said before. This, but somewhere in like before that, it's gonna be warm to hot summer continental climate, or warm to hot summer continental climate.